Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is based on numericals from optics of class 12. First question. In case of compound microscope, two focal lengths are given and distance of object from objective is given. After noting down parameters, note down the formula used for magnification. V naught by U naught into 1 plus D by Fe. V naught is not known, which can be known by using this lens formula. So 1 by V naught will be 1 by F naught plus 1 by U naught. To calculate V naught, put the values. 1 by V naught is 1 by 4 minus 1 by 6. So what I get? 1 by V naught, here LCM is 12. So it will be 1 by 12. So V naught comes out to be 12 centimeter. Put V naught here. So magnification will be 12 by minus 6 into 1 plus 25 by 10. It comes out to be 7 with negative sign. No units for magnification and negative sign shows inverted image. Next question, Young double slit experiment is there. Slit width ratio is given and we know that intensity is proportional to width. So intensity is also proportional to square of amplitudes of the wave. So these are two formulas. When I compare these two equations, I get this relation. And we know that W1 by W2 is 4. So A1 by A2 is 2. So in this way, ratio of two amplitudes is known to be 2. Now, I maxima by I minima. I maxima is proportional to amplitude maximum square. A1 plus A2 ka whole square and I minima is proportional to minimum amplitude ka square. So A1 minus A2 by A2 ka whole square. So when I take ratio, this relation I get. Here A2 can be common, but when it comes out from bracket, it comes out as square. So A1 by A2 plus 1 whole square divided by A2 square, A1 by A2 minus 1 whole square. This A2 will cancel and put value of A1 by A2 here. What we get? When I put the value, it comes out to be 2 plus 1 ka whole square divided by 2 minus 1 ka whole square. That is 3 square and it comes out to be 9. Next, in Young's double slit experiment, the fringe width obtained is 0.6 centimeter when wavelength is 4800 angstrom and distance between screen and slit is reduced to half. What should be the wavelength of light used to obtain fringes of 0.0045 meter? Now, fringe width is given, lambda is given, and this distance between source slit and screen is reduced to half. So first formula will be beta equal to lambda capital D by small d. Capital D is distance between slit and screen and small d is distance between slits. D dash is reduced to half. So new lambda dash I have to calculate. Beta dash will be lambda dash capital D dash by small d. Small d will remain same in both equations because there is no change in distance between slits. When I take this ratio, this beta dash by beta comes out to be lambda dash capital D dash upon lambda capital D. Now, what I have to do? I have to calculate this lambda dash. This lambda dash comes out to be beta dash by beta into D lambda by D dash. And this D dash is D by 2. So, lambda dash is beta dash by beta into D lambda by D by 2. So, I get this relation. Beta dash is given to me. I can put this value. Keep in mind that this value is in meter, this value is in centimeter. So convert in meter by dividing with 100. So this will be the value of fringe width beta in meter. Put all the values and calculate lambda dash. In Young's double slit experiment, width of the fringes is 2 millimeter when 6000 angstrom wavelength is used. Find the fringe width if entire apparatus is immersed in liquid. When we talk about change of medium, then wavelength changes by this relation. Wavelength becomes less. So I am not changing distance between slit and screen and distance between slits. It will remain same. Now, what will be the formula for beta? Beta will be lambda capital D by small d and beta dash will be lambda dash capital D by small d because these are not changed. So these two terms will remain same. When I take ratio, this beta dash by beta is equal to lambda dash by lambda. And we know that this lambda dash is lambda by n. So beta dash by beta is lambda by n into 1 by lambda. So what I get? Beta dash will be beta by n. So in this way I can calculate beta dash. Now next question. A slit of width A is illuminated by monochromatic light of wavelength 615 nanometer at a normal incidence. Calculate value of D when the first minimum falls at an angle of diffraction of 30 degree and the first maximum falls at an angle of diffraction of 30 degree. Now wavelength is given, distance, this slit width I have to calculate D. Here it is represented by A. That means D is A, which I have to calculate. In general, D sin theta equal to n lambda for minima and D sin theta equal to 2n plus 1 lambda by 2 for maxima. N is 1 in both the cases. D is replaced by A here. I have to calculate A. So when first minima falls at an angle of diffraction of 30 degree, N is 1. So what I get D sin theta is lambda. Actually, A is lambda by sin theta because here D is A. Put the value of lambda and theta and calculate E. When first maximum falls, then this formula to be used, N is 1. So A sin theta, because D is A here. So A sin theta equal to 3 lambda by 2 and A can be known 3 lambda by 2 into 1 by sin theta. Put value of lambda and theta, calculate value of E. Thanks for watching this video. Like, share, subscribe my channel.